Hi everyone. We're continuing our march through the practice test for Chapter 3 on linear regressions. So let's get on with it with Part 2 of our Chapter 3 practice test. The manager of a water park collects data on the daily high temperature and the number of customers entering the water park, for 15 summer weekdays. Based on the data, he produces a least squares regression equation to predict y, the number of customers, based on x, the daily high temperature. The equation is y hat equals negative 3110 plus 51.2x. On one day, the high temperature was 93 degrees Fahrenheit and 1,700 customers entered the park. Which of the following is the residual for this observation? Well, there is no which of the following. Just compute the residual. So I want you to remember that the residual equation is RAP. R equals A minus P. Or the residual is equal to the actual minus the predicted. So we can fill in a lot of this already. We know what the actual temperature is. The actual temperature was, the actual number of customers was 1,700. We don't know the predicted number of customers, so we're going to have to figure that out if we want to find the residuals. Rewriting our regression equation to fit what I'm trying to tell you in this class, we get the predicted number of customers as negative 3,110 plus 51.2 multiplied by the daily high temperature. So let's substitute that daily high temperature. It's supposed to be 93 degrees. Okay, if the daily high temperature is 93, what we compute is that the predicted number of customers will be 1,651.6. Now don't let that 0.6 bother you. If you were interpreting, then you would have to do some rounding here. But since we're just looking at a prediction, that 0.6 really doesn't bother anybody, mathematically speaking. So now we're going to substitute the predicted and the actual into our equation. So we have 1,700 people actually entered the park. We predicted 1,651.6. So our residual here is 48.4. Okay. A few things that you can tell. It's a positive residual. So that should tell you that the actual number of customers exceeded the predicted number of customers. And I'm going to write the word residual here so I don't have to have the extra labor of writing out an interpretation sentence. Since the word residual is there, we're good. 6. The correlation between the number of service calls and the number of copy machines leased is 0.86. About what percent of variability in the number of service calls is explained by a linear relationship between the number of service calls and number of machines? I wonder where I've heard that phrase before. Well, if you've been working with linear regressions, you would probably know that you were looking at the interpretation for r squared. About r squared of the variation in the response variable is accounted for by a least squares regression line with the explanatory variable. So all I need to do is find the value of r squared, and I know what percentage of the variability or variation in the response variable is accounted for by a least squares regression line with the explanatory variable. Right over here, this tells me that correlation is 0.86. So correlation is the same thing as R, and that's equal to 0.86. So, like we said in class, r squared is literally the square of r. So that tells me r squared is 0.7396. And if I go back to if I substitute everything I know into that interpretation, we get that about 74% of the variation in the number of service calls is explained for by the LSRL with the number of machines. So this is really straight off of the interpretations that hopefully you guys have memorized. Can you predict a person's shoe size from their height? Well, a computer output from graph 3 above provides information on the regressional analysis for these variables for 12 randomly selected high school students in England. Both height and foot measurements are in centimeters. So what is the correct interpretation of S equals 1.2223? So in actuality, we don't need to look at the graph 3. I mean, I'm going to scroll up to it. But none of this is really important because the only thing we're asked to do is interpret S from right here. And we're going to do the same trick that we did with the previous problem by going into the sentence frames that we already know. I don't know how anyone does AP statistics without a list of sentence frames. I really don't. So, interpreting S is a standard deviation of the residuals. So an actual response variable is typically about S units away from the amount predicted by the least squares regression line with the explanatory variable. So we're going to copy that in here, and then we're going to fill in all the blanks that we need to. So the blanks here are the response variable, which is shoe size. The next blank here is S, and S was 1.223. What units were we in? And I think they were both in centimeters. So 1.223 centimeters away from the amount predicted by the LSRL with, and what was our explanatory variable? Well, that was height. So it tells you typically how wrong a prediction would be. And on average, a prediction is about 1.223 centimeters away from the actual shoe size. Okay. It gives you an error, really. Typical error. And finally, number 8, well, finally for this video anyways, a researcher finds that the correlation between personality traits greed and superciliousness is negative 0.4. About what percentage of the variation in greed can be explained by a relationship with superciliousness? So, ladies and gentlemen, we have reached a trick question because linear regression only makes sense for quantitative variables. Personality traits are not quantitative. So, keeping that in mind, correlation does not make sense because regression and R are only used for quantitative variables. And if you're being extra, you would say that personality traits are not quantitative variables. So that's it for our second video. We got a couple more to do here before we're done with our Chapter 3 test, and I'll see you guys for the next one.